Hey guys, welcome back to another video. In this video, we are going to see and learn how to get the moment, shear, and reaction of a simple beam using Excel. Having a spreadsheet like this can be really helpful when you are working as a structural designer. Imagine you have to design a house and you have to run 30 to 40 different beams and get the maximum load, maximum moment, maximum shear, and reaction for these beams. Doing this by hand can take a lot longer versus if you do it using a spreadsheet like this. You also need to keep a record of your design, and it is going to be much more easier and organized if you just save the result of each beam after you run the Excel file. You can print it and keep a hard copy as well. This is just one example of how you can design a spreadsheet to run your beams. You can download this and add anything that you like and use this spreadsheet, or you can always create your own, and if you have any question, comment below and I can help you. In this video, we are going to look at the spreadsheet for simple beam with uniform load. First, we are going to see how to make a spreadsheet like this, and after that we are going to solve a simple example using this spreadsheet. This spreadsheet is made using the formulas that you can see on this figure. We have R1, a reaction, R2, other reaction, shear at location X, maximum moment, which happens at this location. We have mx when x is smaller than a. We have mx when x is greater than a and less than a plus b. And we have mx when x is greater than a plus b. Okay, now let's see how we use these formulas in our spreadsheet. First one is R1. As you can see here, this is the formula for it. We have cell N6 multiplied by N9. N6 is RW and N9 is B. That's going to be divided by 2 times RL, 2 times RL, and multiplied by 2 times C plus B. And that's going to give us the result for our first reaction. Next, we have R2, which is our other reaction, and the formula is pretty similar to R1. We just have to change C to A, and that's where we have our K9, which is the value for A. Another thing to mention is if you want to add the units, you can do it from here. Go to format cell, number, and you can make a custom one, which the type gonna be your value, and after that it's gonna be the unit. So you can make the cell to show the unit like this. The next row is gonna be our shear value for when x is greater than a and less than a plus b. When x is less than a, the shear value is going to be equals to R1, as you can see from shear diagram. And when x is greater than a plus b, the value is going to be equals to R2, as you can see from the other side of our shear diagram. So we just wanted to know the shear value in this middle part, and we can get that using this formula. So this is how we show the formula in the Excel sheet. We have if, and if x is greater than a, this is x value, this is a value, and a is less than a plus b, a plus b. If this is true, then we want our value to be this, which is R1, our R1 minus N6 times L5 minus K9. And if this is not true, then the cell should be empty. As you can see, that's how we make the cell empty. So for example, if I put a value which is not in this range, let's put a value equals to 2. You see that the cell is going to be empty. And if we put a value like 5, then we have the value for our shear at 5 meter. So this is going to be the formula. We have the logical test, which is this, and we can add 2 logical tests using AND function, and we have the value if true, which is this, and we have the value if it false. For our maximum moment, again we have the formula in the cell. The formula is R1, our reaction, multiplied by A plus R1 divided by 2W. You have R1, A plus divided plus R1 divided by 2 times W. And then we have the location where the maximum moment happens. And this is the formula for it. A plus R1 divided by W. And we want our cell to show the value like this, at distance M. And that's how we can do that. So we have at the value of the cell and the unit. We have to create a custom type here. Okay, so that was our maximum moment at this location. What if we want to know the value for moment at some other location on this beam? These are the 3 formulas that we can use to get the moment value at different locations. So first one, if the location is x less than a, so in this part of the beam, this is the formula that we are using, and we are using the if function again. If this condition, which x is less than a, satisfied, if value true, this is going to be the value for our moment, and if it's false, just leave the cells empty. For the next one, we have 2 conditions that we want to satisfy. X is greater than a and less than a plus b. So we are using if and AND function. If the first one is true, if the second one is true, then the value that's going to show in the cell is this, which is this formula, and if it's false, then leave the cells empty. And last one, if the x is greater than a plus b, we are using the if function again. If this condition is satisfied, value is going to be equal to this, and if it's not true, then leave the cell empty. Okay, this was how we added these formulas to our Excel sheet. Now let's look at a simple example of how we can use this spreadsheet. Here we have a structure like this. For example, this is a garage, and you want to add this half a story at top of the garage. You have the joist running in this direction. You have this open space here, this open space here, and this open space here. And we have this beam that's going to support the load from this joist. So this joist is going to be supported on this beam and this wall. Okay, now let's say that this floor is supporting 1.92 kPa live load and 1.92 kPa dead load. We have to calculate the load which is going to be on this beam first. We are using the 1.25 dead load and 1.5 live load factors for calculating the load on the beam. In order to calculate that, we have the formula in our cell, which is 1.25 times our dead load plus 1.5 times our live load. And we have to, this is going to be in kPa. We have to multiply that by half of the joist length, which is 4 meter, to get the load in kilonewton per meter. And that's the load that we're going to use here on our beam. Okay, now that we have our factored load on the beam, we can calculate our maximum moment and maximum shear. We have to add the distances. A is going to be equal to 3 B is going to be equal to 5 and C is going to be equal to 2. And after that we can see our values on this part of the spreadsheet. First we have R1, our first reaction, which is equal to 47.52. R2, our second reaction, which is going to be equal to 58.08. We have our maximum moment, 196.02, happening at 5.25 meter. And we can see that the value for maximum shear is 58.08, which is equal to our R2 value. Okay, now that we have the result of this spreadsheet, we can just print it or save it, and when we want to size this beam, we know what is our maximum moment and maximum shear, and we can use this value to size the beam. This is going to be used for ULS design. We also have to take into account our SLS condition, which is going to be the deflection and the vibration, which is not addressed in this spreadsheet. Okay guys, so this was a simple example to show you how a simple spreadsheet can make everything easier, faster, and much more organized. You can always create your own spreadsheet based on the criteria that you want and type of the example that you're solving every day, and this is going to help you a lot and make everything much faster for you. Like always, if you have any question, comment, or suggestion, please comment it below. Also, if you want this spreadsheet, comment below and I can send it to you. Thank you for watching this video. If you enjoyed this video, please hit the like button, please hit the subscribe button, and I will see you in next video.